In this video, I want to talk about the stem plot, or the stem and leaf diagram. In the stem plot, we take quantitative data like the temperatures that we saw in the last video that I'm going to use again. And again, those temperatures come from July and August at PTI, Piedmont Triad International Airport in Greensboro, North Carolina. To draw a stem and leaf plot, we look at our quantitative data, and we imagine dividing the data into two parts, a stem and a leaf. And so for two-digit numbers, it's often convenient for the leftmost digit to become the stem and for the rightmost digit to become the leaf, or the tens and ones digits to become the stem and leaf, respectively. Now, sometimes in a stem and leaf plot, you just take the possible tens places, and for us, our data here are in the 70s and 80s. The lowest value is 78, and the highest value in this data is 95. And so I could imagine just taking the possible tens places and writing them down. And then what I would do is write next to them the corresponding ones digit. So there's a 78, so I'd write an 8 there, and then whoever's reading this knows there's a 7 and an 8. Right? There's a 78 in the data set. There's some 80s and an 81, so I could imagine writing it out like that, and someone could say, well, there's an 80, there's another 80, and there's an 81. And so in that way, the stem plot actually can be used to reconstruct the data. Because I only have data in the 70s, 80s, and 90s, I'm going to split up things into a little bit so we see a little bit more information. So instead of just having one spot for the 70s, I'm going to place two. Same thing for the 80s, and same thing for the 90s. The first spot for each one will be used for the ones places 0, 1, 2, 3, and 4. So anything from 70 to 74 would go here. 75 through 79 go here. 80 through 84, 85 through 89, 90 through 94, and then 95 through 99. And this will give us a little bit more information visually. So what I need to go and do now is write out all the data. One way to do that would be just to start here with the 87 and write a 7 where it goes, right? I have an 80 and a 7, right? It's an 87, and it goes in the second spot for the 8 because it's more than 85. But in our last video, we constructed a dot plot. And I just happen to have that dot plot right here. And it's nice that we've constructed that dot plot because that lets me summarize the data in order. So I can go through here and write down the stem and leaf plot using the dot plot that I've already done. Now, if I hadn't constructed the dot plot already, I would just use the data. I would not do this as a first step if it didn't already exist. All right, the only data points I need to worry about being in the 70s are a 78 and then 3 79s. So I'm going to leave this spot for the 70s, 70 to 74 blank. I'm not going to write a 0 in there because if I write a 0 in there, I'm telling someone there was actually a 70. And there wasn't, so that would be misleading. So I have to leave that one blank. And I'm going to include it there and leave it blank so whoever's reading this knows there was no data there. There was nothing between 70 and 74. All right, next up I have 3 80s, right? I had 3 dots over that, so I need 3 zeros. There's no 81s, but there's an 82. And then there are 4 83s. There are, how many 83s? There are 4 83s, so I got those. There are 4 84s. So already I can tell there's a whole lot of data in this row. The next data point's an 85. There are no 86s, but there are 1, 2, 3, 4, 5 87s. There are 6 88s. Oh, and if I was doing this on a lab or an assignment that I was going to turn out, I'd grab my ruler and make those lines a little neater. All right, there are 7 89s. I'm going to double check that. 1, 2, 3, 4, 5, 6, 7 89s. Moving on to the 90s, I see 390s and 391s. And then the only remaining data point is a 95. Looking at this stem plot, I can also think about the distribution of the data. I can think about the length of each row in the same way that I would think of the height of a histogram bar, right? I see there's a whole lot of data in that row. To do a stem plot right, we need the numbers to line up in columns so that we get a true measure of which had the most data. But I see the most data here. And again, maybe I get a shape that's just a little bit skewed one way or another. Now this does give us a different representation of our data than the dot plot did, because we're breaking up the data differently. This puts a dot over every number, and this combines things into classes. So we get a little bit of a different peek into the distribution. One of the cool things about both the dot plot and the stem plot, you can use them to reconstruct the original data. It's a neat way of summarizing data in print that gives whoever's reading it the actual data.